Hello. I had a question regarding the present value formula, which I thought was a really good question because I didn't explicitly go over this formula in previous videos. And so what I wanted to do is go ahead and give you the information that you need to know about the present value formula. Now, one of the reasons why I don't explicitly go over the present value formula is because that actually just comes from something we already know how to do. So based on the compound interest formulas, the generic or general one, we have the amount, like the total amount is equal to the principal times 1 plus the rate divided by the number of times compounded, all of that to the nt, or the number of times compounded times time in years. So we saw that in the compound interest part 2 video. We use this compound interest formula to find out typically the amount that will be in the account at a certain rate, given a certain principal over a certain amount of time, compounded a certain number of times. And so typically we solve this for what is A, okay? When we look at the present value formula, it essentially is the same formula, but instead of solving for A, we solve for P, which is just the amount total that's been accrued divided by that 1 plus r divided by n to the nt. Okay, so the reason why I don't explicitly typically go over the present value formula is because we don't necessarily need it in order to solve for what should my principal be. Okay, so let me show you what I mean. Here's an example where you could use either the compounded interest formula or the present value formula to solve it. So if the question is how much principal should I invest to make $150,000 at a rate of 2% compounded quarterly over 5 years, the question isn't asking you how much will I have in 5 years. It's telling me how much I will have in 5 years. And I have to figure out how much money I need to invest now in order to have that amount in 5 years. So let's write down our two formulas. So on the left-hand side, we have our compounded interest formula, and then we have our present value formula. And so what we're going to do is we're going to substitute in the values that are provided to us in the question. So I'm going to do that both for both equations, for both formulas. One of the first things I'm going to do is I'm going to address what my A is, what my rate is, what my N is, how many times it's compounded, and my total time in years. And then I'm going to go to each of these formulas and substitute those values in. So here are the values substituted in. So one thing I want you to note is that when I have a variable that I'm solving for and it's being multiplied by something else, in order to solve for that variable, I would divide that side of the equation by the other thing that's being multiplied by. So in a nutshell, or with a much smaller example, if I were to say, let's say 21 equals 3x, and I wanted to solve for x, I would divide both sides by 3. So I would end up with 7 equals x. So in this case, on the left-hand side, using the compound interest formula, to solve for p, I would just take this side of the equation and divide by this entire 1 plus 0.02 divided by 4 to the 4 times 5. Okay, but what I do on one side of an equation, like I did here, I have to do on the other side of the equation to keep it balanced. So I would take this and divide by that same value. And so when you divide a number by itself, that cancels out to just 1. So you end up getting P equals 150,000 divided by 1 plus 0.02 divided by 4, all to the 4 times 5, or to the 20th, right? Which is exactly the same as what you get from the present value formula. So one of the things I think is kind of important is sometimes understanding that if a formula can be derived from another formula, it might not be worth the necessarily like space or storage in the brain to remember or memorize both formulas, because you can definitely solve for what should my principal be to end up with a given amount in the account that you want at the end of a certain amount of time, you can use the compounded interest formula to figure that out. But if it helps you to understand and learn a whole separate formula, that's totally fine. So, anyway, at the end of the day on this problem here, using my scientific calculator, I end up getting $135,759.44. So that's how much I should invest today, present day, if I wanted to make or have $150,000 in my account after 5 years. That's compounding at 2% quarterly. So, anyway, I wanted to make sure you saw that and understood that. If you have any questions, please let me know. Again, you can memorize or look at this present value formula, but please understand that it's just a way to rewrite the compound interest formula where you're solving for the principal instead of solving for the amount at the end.